Okay guys, so in this video we are going to try to come up with some shortcuts to help us simplify products of powers and quotients. So the first example shows you 5 to the third times 5 squared, which means 5 times 5 times 5 3 times. So 5 to the third gives us this. And then 5 to the second gives us this. And so when I write it in exponential form, that gives me 5 to the fifth power. If I look at the next one, I've got b to the sixth, which would be written out as b times b times b times b times b times b 6 times, times b to the second, b times itself twice, which gives me a total of b to the eighth power, if I count. 1, 2, 3, 4, 5, 6, 7, 8 b's in total. If I look at the next one, I've got y to the second, y times y to the 10th, y times itself 10 times, 3, 4, 5, 6, 7, 8, 9, 10, times y to the fourth, run out of room here, which gives me a total of, if I count them up, I've got 2 plus 10 plus 4, which gives me a total of 16 y's. And then if I look at the last one says 3 times x times x times y times 2 times x times x times y times y. I'm just expanding it all out. So if I look at the 3 and the 2, 3 times 2 gives me 6. X times x times x times x, so 2x's here and 2x's here gives me x to the fourth. And then y here and 2y's here gives me y to the third. So if I look back at all of these and I look at the exponents that I started with, so I started with 5 to the third and 5 to the second, that gave me 5 to the fifth. Over here I had b to the sixth and b to the second, that gave me b to the eighth. Here I had y to the second, 10th, and 4th, which gave me a total of 16. And then here I had x squared and x squared, which gave me x to the fourth, and y to the third was from 1y and 2y's. So the way that the shortcut that I'm noticing is that I'm going to add my exponents to get my final answer. So when I'm multiplying two exponents together, I'm actually adding the exponents to get my final answer. So if I have x to the a times x to the b, that's really going to be x to the a plus b. I'm going to add a and b together. So let's look at some examples. If I have x to the fifth times x to the third, thinking in my head, this is really 5x's multiplied together and times 3x's multiplied together. That's going to give me x to the eighth power in total. I'll have 8 x's multiplying each other. Then I have x to the 40th and x to the third, which is going to give me a total of x to the 43rd. I only want to add the like base exponents. So if I have a to the third, I only want to look at other a's. So I have a to the sixth, which gives me a total of a to the ninth. And then if I look at the b's, I have b squared and b to the third, which is going to give me a total of b to the fifth if I look at just those. So if I had x squared y cubed times 3x to the fourth y to the fifth. First of all, this 3 has no other things to multiply. So this is just going to give me 3 in front. And then I've got x squared and x to the fourth, so that gives me a total of x to the sixth. And then I've got y to the third and y to the fifth, which is going to give me y to the eighth. If I look at the next problem, I've got a times a to the third. We talked about how a is really a to the first power. So if I have a to the first times a to the third, 1 plus 3 is going to give me 4. A to the fourth. In F, I've got this 8 out in front. That 8 has nothing else to multiply, so it's just going to stay 8. And then I have a really to the first power and a squared, which gives me a total of a to the third power. And then I have b to the fifth, and then really b to the first, which gives me b to the sixth power. In the next one, I have two numbers in front. I've got 2 and 4. A lot of people want to write 6, but I'm multiplying. So if I multiply 2 times 4, that gives me 8. And then I've got x to the first and x to the second, which gives me a 1 plus 2 is 3, x to the third. I've got y to the first and y to the third, which gives me a total of 4 y's, y to the fourth. And then z has nobody to multiply with, so it's going to remain z to the first. So we've looked at the product of powers, so when I've multiplied them, now I want to look at what happens if I divide them. So if I expand out 3 to the fifth over 3 to the second, I've got 3 times 3 times 3 times 3 times 3 divided by 3 times 3. 3 divided by 3 is 1. And so is another 3 divided by 3. So really, 2 pairs of 3's don't even matter. And I'm left with 3 to the third power. In my next one, if I have a times a times a times a over a times itself 3 times, I've got 1, 2, 3 pairs that cancel out. So I'm left with just one a to the first. If I've got b times b times b over b times b times b times b times b, I can do the same cancellation. And I'm left with 2 b's in the bottom, so I have 1 over b squared. And then the last one, I've got 5 4's in the top. I've got 7 x's in the top. I've got 2 4's in the bottom and 4 x's. So if I cancel out things that make 1, 4 divided by 4 makes 1, 4 divided by 4 makes 1, x divided by x, x divided by x, x divided by x, x divided by x all make 1. So I'm left with 3 4's, 4 to the third, and I'm left with 2 x's, x to the second. And so if I look at all of these, I think you probably already picked up on the pattern. 3 to the fifth divided by 3 to the second gave me 3 to the third. A to the fourth over a to the third gave me a to the first. And so if you notice, we are subtracting the powers, the exponents, when we divide. So if I have a to the m divided by a to the p, all I need to do is subtract the two exponents, m and p, to get a simplified exponent. So let's try a couple of these. First of all, this 6, kind of like before, has nothing to really divide with, so it's going to remain 6. But then if I look at c to the fifth and c to the second, since they're like bases, I'm going to subtract to get c to the third. If I look at the next one, a to the seventh over a to the first, if I subtract those exponents, gives me a to the 6th. B to the 10th over b to the 3rd. 10 minus 3 is 7, so b to the 7th. And then c has nobody to divide with, so it's just going to stay down in the denominator, over c squared. In the next one, x to the 20th over x to the 15th is x to the 5th. 20 minus 5, 15 is 5. Y to the 15th over y to the 14th is y to the 1st, or just y. When it comes to just numbers, we want to divide. So it's not 4, but 6 divided by 2 is 4. This one's kind of tricky because I have 2 in the top and 4 in the bottom. So if I do 2 minus 4, I get -2, which we're just going to leave like that for now. So this would be 4x to the -2 because 2 minus 4 is -2. In the next one, 8 divided by 2 is 4. S to the 12th divided by s to the 10th is s to the 2nd. 4 minus 3 gives me t to the 1st. And 3 minus 1 for the u gives me u to the 2nd. If I do 2 over 8, that's not 4. 2 divided by 8 is 1/4. And then m squared divided by m to the 5th. 2 minus 5 is -3. And then 5 minus 2 for n gives me +3. And we're going to leave our answer like this for now.